In this video of the algebra series, we will be taking a look at rearranging formulas. Now, a few things that we're going to go over is rearranging formulas to make x or any letter the subject. And after that, we'll take a look at a few harder examples where the subject appears twice. And to wrap up, we will go over some practice questions. Now, starting off, we have a question here. We need to make x the subject of the formula a equals x minus b over y. Now, the first step that I like to take in these questions is trying to make this equation linear, and by that I mean getting rid of any brackets and in this case any fractions. So what we can do is we can get rid of this y, we can take it over and multiply. So that would give us a y equals x minus b. Now we want x to be the subject, so we want to get rid of this minus b so we can take it over to the other side. So therefore ay plus b gives us x. Moving on to some more questions. Here we need to make v the subject of the formula m brackets v minus u equals I. So what we can do here is it looks like it would be easiest if we move this m over to the other side first. So if we're multiplying by m on this side, we're going to be dividing by m on the other side. It will leave us with v minus u equals I over m. Now we want v on its own, not v minus u. So we need to take this over to the other side, which will leave us with v equals I over m plus u. For the second question, we need to make u the subject of this formula. So we can start off by getting rid of this term here. So if we take that over to the other side, we're adding on this side. So when we take it over, we're going to be minusing. Now we want u, not u squared. So if we're squaring on this side, we're going to square root on the other side. So the square root of v squared minus 2as gives us u. For this third question, we need to make w the subject of this formula. So as we said before, let's try and make it linear. Let's try and get rid of everything extra that we have here. So we've got a square root sign, so we're square rooting on this side. If we take it over, the opposite of square rooting is squaring. That would give us h squared equals w over I. Now we want just w on its own, so we need to get rid of this I. We're dividing on this side, so if we take it over, we're going to multiply. H squared I gives us w. Okay, last question here. We need to make a the subject of this formula. So what we can do is let's multiply out this bracket and then rearrange to get a on its own. C equals 6ab plus 9. So now this equation is a bit more easier to rearrange. So starting off, let's get rid of this 9. Now we want just a on its own. Now at the moment we have 6 times a times b, so we can get rid of 6 and b to leave a on its own. And on this side we're multiplying by 6b, so if we take it over we're going to be dividing. So we're going to divide this whole left side by 6b, which gives us just a on its own. Okay, moving on now to some harder questions. Now, we may get some questions where the subject appears twice, so we just need to add in a couple more steps to solve this. Starting off, as mentioned earlier, I like to make the equation linear, so try to get rid of any fractions, expand brackets when necessary, and then we need to rearrange the formula to get all of the subject terms on one side and all of the non-subject terms on the other. Once that's done, because the subject appears twice on one side, we would need to factorize and then move the bracket over to the other side, so we're just left with one letter. Now let's actually apply that to this question. So we need to make A the subject of this formula here. Now, as you can see, A appears twice. Now let's go ahead and follow our process. So let's make it linear first of all. Let's take this fraction over. P brackets n plus A equals n squared plus A. Let's multiply this bracket out. So Pn plus AP equals n squared plus A. We need to make A the subject, and at the moment we've got A on the left hand side and A on the right hand side. So what we want to do is get all of the A's on one side and all of the N's on the other side, and then that will give us n squared minus P, which equals AP minus A. So now, as you can see, we've got all of these subject terms on one side and the non-subject terms on the other side. However, we still have A in both of these terms. We want just one A. And the way we're going to do that is we're going to factorize. So if we take A out of this equation as a common factor, we will get A brackets P minus 1 equals n squared minus Pn. So now you can see we've got A on its own now, just as a single term. Let's get rid of this bracket here. Let's take that over. So A therefore equals n squared minus Pn all over P minus 1. Looking at a few example questions now. Let's rearrange the formula x brackets 2 plus a equals b brackets x plus 3 to make x the subject. Now, as we can see, we have x on both sides of this equation. So what we're going to do is, to make it easier, let's multiply out these brackets first and then rearrange accordingly. So that will give us 2x plus ax equals bx plus 3b. Now we want to get all of the x's on one side and all the other terms on the other side. So we can see here we've got x, x, and x here. So let's take this term over. That will give us 2x plus ax minus bx. Now x is a common factor in all three of these terms, so let's take that out. Which equals 3b. We can go ahead and take this bracket over, leaving us with x equals 3b all over 2 plus a minus b. Taking a look at question 2. So here we need to make v the subject. First of all, let's go ahead and make this equation linear. Let's get rid of this fraction so we can take this denominator over to the other side. We're dividing on this side here, so when we take it over, we're going to multiply. That will give us j x plus v equals xv. let's go ahead and multiply out. So jx plus jv equals xv. Now we want v to be the subject, so we need all the v's on one side and all the other terms on the other side. So we can take this term over here and this term, because it's x, over here to the other side. That gives us jv minus xv equals minus jx. Now we've got all the v's on this side, so we can take that out as a common factor and put in the brackets j minus x, which equals minus jx. We want v on its own, so let's take that over, leaving us with v equals minus jx all over j minus x. Okay, passing it over to you now. Please pause the video here and attempt these 3 questions, and we'll go over them together once you're done. Okay, so for this first question here, we need to make p the subject of this formula. So let's go ahead and multiply out this bracket first. So m equals 2a plus 2p squared. If we take this term over, we get m minus 2a equals 2p squared. We can take this 2 over as well. That gives us p squared. Now we want p on its own, not p squared. So if we're squaring on this side, the inverse will be square rooting on the other side, giving us a final answer of m minus 2a over 2 square rooted, which equals p. In question 2, we need to make x the subject of this formula. So let's go ahead and make it linear first of all. Let's get rid of these fractions. So what I can do is I can take this q over to that side and then take this x plus c over to the other side. And we're going to be multiplying on both sides. So that will give us xq on the left-hand side, and on the right-hand side, p brackets x plus c. So we can multiply that out, which gives us px plus pc. Now we want to get all of the x's to one side, so we can take this over. X is a common factor, so we can take that out. Now we want x on its own, so take this over, leaving us with a final answer of pc divided by q minus p. For this last question, we need to rearrange this formula to make b the subject. So what we can do is, as mentioned previously, we want to try and make this linear, so we can get rid of this fraction here. So we're multiplying by a third on this side. When we take it over, we're going to divide. So v divided by 1 over 3 is the same as v multiplied by 3 over 1, which just gives us 3v, which equals pi brackets a squared plus b squared. Next we can take the pi over. 3v divided by pi equals a squared plus b squared. So as you can see, we're rearranging this one term at a time, step by step. Next we want to get rid of this a squared, so we take that over 2. Now this gives us b squared. We want b on its own. So if we're squaring on this side, we will be square rooting on the other side. Therefore 3v over pi minus a squared, all square rooted, gives us b. So I hope you can see how we can take complex formulas like this and rearrange them one term at a time. And that is the easiest way to do these questions. We don't want to rush anything. Just one by one, we'll take our time and that will get us to the correct answer.